Welcome to the Unit 6 Day 4 notes. Go ahead, pause the video and work out this warm-up. I mentioned the answer to this during class for the Unit 6 Day 3 notes. So go ahead and see if you can remember what that is, then unpause it and see if you got it right. So it says, when you're graphing the image of a reflection, what property from Unit 5 allows us to count up or down to the line and then left or right that same amount? That has to do with squares, because you're making a square. So the diagonals of a square are perpendicular to each other. Okay, because remember, normally we would count up. Like if we were going across the x-axis, we would count up or down to the line and then just keep counting that same amount again. Same with if we were going over the y-axis, we'd go left or right, because that is perpendicular to that axis. If we're going across a line that is not perfectly vertical or perfectly horizontal, we still need to count perpendicularly. That's the way we reflect. All right, so today we are going to talk about rotation. Rotation is probably going to be the trickiest part of this unit. Trying to do electronically and virtually. It's going to be a little bit tricky. So there are a few things we need to know about. First off, we need to know directions. So we either go clockwise, which we usually abbreviate CW, or counterclockwise, which we abbreviate CCW. If you don't know which direction you are going, you have a 50-50 shot at guessing, and one's going to be wrong. Okay. Counterclockwise is going to be used probably the most often. But all of these rotations happen, we say, about a point. All that means is that we are going around a specific point. So about just means around. Okay. If you don't specify what point you are rotating around and what direction, you're not really describing a rotation. So for this example, we are going to say we have a rotation 90 degrees clockwise about point P. Okay, in this case, I'm going to say P is the origin. I forgot to put that in the picture. The way this actually works is in the way that we measure this angle is if we were to connect point A to point P and connect point A prime to point P, we would measure this angle. Okay, and I'm telling you it's a 90-degree angle. The way we would be able to figure this out for what you guys know at this point in your math careers is we found the slope of AP. Okay, that slope is going to be 2 minus 0 over negative 1 minus 0, which is negative 2. And then the slope of A prime P would be 1 minus 0 over 2 minus 0, which is positive 1/2. So since they have opposite slope, opposite reciprocal slope, we know that segment AP is perpendicular to segment A prime P prime, and if they are perpendicular, that means they form a right angle. So that's how we get that would be a 90-degree angle. You would also be able to say that about BP and B prime P. That's still a 90-degree angle. We rotated everything the exact same amount. Not every rotation is going to be 90 degrees. In this class, we are going to pretty much stick with 90, 180, and 270, because those are all multiples of 90. But you could rotate this any amount that you want. And what's happening, remember A and B go to A prime, B prime. This blue segment moves over, and at the end of the rotation would land right on top of that black segment. So our rules for rotating about the origin, okay? These all work for around the origin, which is 0, 0. And these are all the rules for if we are going counterclockwise. So if we are rotating 90 degrees counterclockwise, okay, I'm going to draw a quick little silly picture for this. If I'm rotating 90 degrees counterclockwise, That's the same thing as if I had gone that direction, 270 degrees clockwise. You can get there two different ways. So every answer pretty much has two possible answers. All right, so we're going to take a point AB, and that's going to now end up at the point negative BA. We're going to do an example where we actually use a physical point. So I'm going to use the point 1, 3, where that is A. Similar to when we did the reflection, I'm going to do this as 3 separate problems. I'm going to have 3 separate A primes. Normally you would have just one A prime and then A double prime, but I'm going to constantly be moving this black dot. So according to the rule, I would have A prime, I'll use red here. I would have A prime if A was 1, 3, like I said. A prime would then be negative 3, positive 1. Okay, that's from number 1. Normally, we would use tracing paper, which makes this really, really simple. Unfortunately, we don't really have tracing paper. You might have some at home. That's awesome. What I'm going to recommend that you do is that for all these problems, you have at least one piece of paper next to you so that you can kind of sketch something and then use your iPad to physically rotate. So I would say grab your iPad in both hands. If this thing says rotate 90 degrees counterclockwise, all that means is you're going to take your right hand and you're going to turn like you were turning a car to the left. So if, like I have my iPad started right now the long ways, so when I turn 90 degrees counterclockwise to the left, my right hand is above my left hand, and the iPad is standing the tall direction. All right? If you start with the tall, then you would go to the horizontal direction. That'd be a 90-degree rotation. So make sure you lock your screen. Should have said that. As you turn 90 degrees to the left, counterclockwise, you can just look at where point A is on that graph. Ignore that this is normally the X and this is normally the Y axis. When you have this thing turned, now pretend this is your X, this is your Y, you'd count left 3, up 1. That's negative 3, 1. So this is where that paper comes in handy. You just look at your iPad like this, and draw it off to the side on your piece of paper, then you can turn it back, look at your piece of paper. Now that your iPad is back in the normal direction, where this is your X-axis and this is your Y-axis, it said, oh, go left 3, up 1. That's where your A prime is. All right. This is something that's kind of really hard to explain since I can't actually see you and you can't see me. There's a lot of physical manipulation happening. All right. For the second one, if I rotate 180 degrees counterclockwise, that's the exact same thing as if I'd gone 180 degrees clockwise. They're the exact same thing. So the rule for this is just you take whatever your A and B value are and then you change it from positive to negative or negative to positive. So since A was 1, 3, this should now become negative 1, negative 3. Okay, similar thing. I'm going to have this iPad in my hand horizontally, hands on both sides. If I'm rotating 180 degrees, I'm going to just turn it completely upside down. So now it's still left and right, just going the other direction. And if my screen's locked, all my words should be upside down. I would then just look at where my original dot was, which would say left 1, down 3. All right, so then I write that off on the side on my piece of paper, bring my iPad back to normal. It said go left 1, down 3. Now look at the origin, left 1, down 3. All right, so A prime is negative 1, negative 3. And then the last one, if I'm going 270 degrees counterclockwise, that's the same thing as going 90 degrees clockwise. And this time when I'm rotating, so I've still got the iPad in the long direction, screen locked. This time turning 90 degrees clockwise or turning 270 degrees counterclockwise is the same thing as just taking your left hand and bringing that to the top. So now I can look and say that my original dot A is 3 spots to the right and 1 spot down. Mark that on my piece of paper. Come back and say it's 3 spots to the right and 1 spot down. Okay, so my rule, which I didn't put down, is just B, negative A. It's the opposite thing from number 1 because we went the opposite direction. All right, so these are all the rules for rotating about the origin. If I'm not rotating about the origin, I know I have a few problems in the homework, so I'm going to quick explain how that would work. Here's my origin. If I had the point, I'll say this is 2, 2, and I want to rotate around that point instead, what I would just do is basically draw a new axis right here. And then this point, which would be 3, 2, I'm going to pretend is just 1, 0. And then you'd use your same rules, and you just have to count separately. That's something that you might have to kind of play around with a little bit. It'll be easier if you ask a question during one of our classes, just because it is something that is harder to see. All right, so for this example, all it says to do is find the transformation. At this point, we have 3 different types of transformations. We have translations, or slides, reflections, or flips, and then rotations, which are just turns. Right away, I can acknowledge that the physical shape is the same, but I have to pay attention to the actual points. So like this point right here is D and D prime. That tells me immediately that it is not a translation. It's either going to be a reflection or a rotation. All right. Well, if it was a reflection, B would go to B prime. That makes sense. But then C would have to go over here. That doesn't really make sense for a flip, because then if I'm flipping C over to here, B would have to end up here. So that flip doesn't work. So this is a rotation. Anytime I give a rotation, I have to give 2 things. I have to give a direction and a degree. So my options are going to be 90, 180, or 270 degrees. Well, if I went 90 degrees, since this is a square, okay, if I went 90 degrees, C would have to end up where A prime is. So it's not 90 degrees. So I've got to go the next one, which is 180 degrees. So 90 and 90 brings you to C prime, B to B prime, and A to A prime. So this is a rotation 180 degrees. You got to pick a direction. When it comes to 180 degrees, it does not matter which one. You need counterclockwise or clockwise. They're the exact same, only for 180 degrees though. So I'll pick counterclockwise, and then you have to say about which point, about where are you rotating it around. So you are rotating it around point D, so about point D. Also, I'm sorry about my dog whining over here. He thinks that it's time to play. So if he whines too much, I apologize. So for the next question, we want to rotate the quadrilateral RSTU with vertices R 3,1, S 5,1, T 5, -3, and U of 2, -1, 270 degrees about the origin. All right, so first thing we're going to do is we're just going to graph the original thing. So, also, he just found one of his squeaky toys, so I might have a couple of squeaks here in a little bit. I apologize. So, we're going to start with R is at 3,1. S is at 5,1. Then we have T at 5, -3. And we have U at 2, -1. So RSTU, we have that. All right. So if I want to rotate this thing 270 degrees about the origin, it doesn't tell me a direction. So if it doesn't say which direction, that is always going to mean counterclockwise. If it does not specify a direction, the assumption is it's going counterclockwise. So I need to move each of the points. So I'm going to use green for my image. So I'm going to take R, which was 3,1. That's going to R prime. Because of our rule, that means we're going to put the Y value as our X value, and the X value, change the sign, make that our new Y value. All right. Same thing with S. S was at 5,1. That's going to go to S prime, which will be 1, -5. T of 5, -3 becomes T prime, which is -3, -5. Or U, which was at 2, -1, goes to U prime, which is -1, -2. Those are using our rules. Using the rules gets kind of confusing when you have negative values like we have with U and T. So I'm literally going to tell you on a piece of paper right next to your iPad, you're going to draw a quick coordinate system, all right? You are going to hold your iPad in your hand. We're going 270 degrees counterclockwise. So that's the same thing as just taking your left hand, bringing it to the top. I'm going to look at my picture. This is my new x-axis. This is my new y-axis. So for the R, I had to go right 1, down 3, which is what we said over here. For S, we had to go right 1, down 5, which is what we said right there. For U, we had to go left 1, down 2. And for T, we had to go left 3, down 5. All right, so to graph that, I would come back, have my iPad facing my normal direction. I'm going to have 1, -3 for R, 1, -5 for S, -3, -5 for T. Oops, put that in the wrong spot. And -1, -2 for U. But these are all prime, so make sure you put the prime by them and then connect the dots. R went to S, so R prime goes to S prime. It's the same thing right there. Now, I messed up where I put T because I got distracted by my dog trying to flip my computer. So I'm going to fix that real quick. I went to -5, -5. Should have gone left 3, down 5. One way that I noticed that I made that mistake right away is just like with reflections and with translations, rotations are isometric. It's an isometry, so my image needs to be the same size and shape as my pre-image. So like the length of ST was, well, S to T went 1, 2, 3, 4. So S prime to T prime should go 1, 2, 3, 4. All of those measurements still need to be the exact same size. All right. Now, next up, we're going to talk about rotational symmetry. So rotational symmetry is something that's probably pretty new. I know you've heard about line symmetry in the past or just symmetry in the past. We talked about line symmetry in the reflections notes. So rotational symmetry, I'm going to give kind of a somewhat of a nice definition. We're just going to say looks the same after a rotation of X degrees. When I say looks the same, I mean if you were took off all of the identifiable features. So in this case, we have A and A prime. If you took off A and you took off A prime and you turned this, like someone turned it while your eyes were closed and you opened your eyes, you wouldn't be able to tell if it had been turned or not. We just know that it's going to have these points, and that's how we know it's been rotated. All right? So we're rotating X degrees, where we're going to have X be between 0 and 360 degrees. All right? The reason we say 360 degrees is because that's one full rotation. If I rotate this star 360 degrees, A is going to end up at the very top. So I'd have A prime at the top. All right? Now, I can figure out how far we actually rotate these things. So that's what these next examples are going to be. It says, describe the rotational symmetry that these objects have. First thing you want to do, look for line symmetry. Or look for lines of symmetry. In the rectangle, we have 1, 2 lines of symmetry. The diagonal does not work, because if you were to fold like a piece of paper in half diagonally, they're not going to line up on the edges. So you have 2 lines of symmetry. So it says, describe the rotational symmetry. We have rotational symmetry in this. Okay? And to describe it, we're going to say 180 degrees. None of that makes sense to you right now. Okay? Hold your iPad in front of you. Okay? If you turn the screen off, you don't have to. If you turn the screen off and you turn this thing 180 degrees, you would have what was on the top is now on the bottom. It would still look like a rectangle. It looks the exact same thing. It has the same length across the top and bottom, the same lengths on the sides. If you had turned it 90 degrees, it's not the same thing because now it's taller than it was or shorter, depending on how you have your iPad in front of you right now. The way we find these values is we take 360 divided by how many lines of symmetry that we actually have. Okay, there are 2 lines of symmetry, so 360 divided by 2 is 180 degrees. All right, that's our rotational symmetry. So for the square, we've got those same 2 lines of symmetry, but the diagonals also work. So this time we have 4 lines of symmetry. Since we have 4 lines of symmetry, we have rotational symmetry. We're going to take 360 divided by 4, which is 90. Now this is where it's a little bit different. When it says describe the rotational symmetry, you are going to take this number, which is 90, and you're going to add 90 as many times as you can until you get to 360. So I have 90. 90 plus 90 is 180. 180 plus 90 is 270. If I added 90 one more time, I would get back to 360 degrees. But as we said right here, it's less than 360 degrees. Not or equal to. All right. So to describe the rotational symmetry of that square, if you turned it 90 degrees, 180 degrees, or 270 degrees, you would still have a square where you've got the sides parallel on top and bottom and on left and right. Okay. For the triangle example, if I draw in a line right there, I have 1 line of symmetry, 2 lines of symmetry, and 3 lines of symmetry. So I'm going to say 360 divided by 3 is 120. So yes, this thing has rotational symmetry at 120 degrees and 240 degrees. I don't write 360. You will never write 360. You'll not write a number bigger than 360 for these answers. Now these first 3 all had yes as an answer. I kind of just said yes right away and didn't really give much of an explanation. Okay, but for all of those, if you took it and rotated it, these degree amounts that we found, you would have the exact same shape. In the last example, that arrow, we have 1 line of symmetry. If you take 360 divided by 1, that equals 360. I said we're never going to write 360 for rotational symmetry, so describe the rotational symmetry. It has no rotational symmetry. If you have 0 or 1 line of symmetry, you do not have rotational symmetry. If you have more than 1 line of symmetry, then you have rotational symmetry, and you'll find those angles by taking 360 divided by those number of lines of symmetry. So like I mentioned in the reflection notes, it's important that you're able to find out all of the possible lines of symmetry, because if you miss one, all of your angles are going to be off for rotational symmetry. All right, so here's your homework. You want to do number 12 and number 24 together. Okay? They're related to each other. And then, I guess I didn't write it down explicitly, but rotational symmetry is equal to 360 degrees divided by number of lines of symmetry. All right, so make sure you're working on your homework and then ask any questions that you have when you have them. I hope everybody has a great day.